So, good morning. Myself, Dr. Lingaraju, Government Fashion Degree College, Tumpur. So, in the physics topic, today we'll discuss the paper Semiconductor Device, Digital Electronics, Laser and also Optical Fiber. Subtopic is Acceptance Angle for the lasers. So, last class we discussed in the optical fiber, for the propagation, total internal reflection is very important. And refractive index of the core medium, water medium, cladding medium, air medium is also we discussed. So knowing all these things, so today we discuss some learning things, that is to know about the acceptance angle and to learn driving an equation for it. After knowing that, we are going to get the information or derivation learned for acceptance angle. So acceptance angle means, so it is a one kind of a half angle of acceptance. In this angle, if any propagation of light signals takes the total internal reflections, leads the propagation mechanisms, that is we call as acceptance angle. So we are going to just give you example for acceptance angle. Means if we having our home means door, through the main door only we can enter inside the home. Similarly, acceptance angle means in this angle only, in this area and also particular angle only, if the light will be enters in the optical fiber, that takes the propagation mechanisms. So that is the concept of acceptance angles. Next, after knowing all these things, so we know we are discussed about the nature of the optical fiber. We know optical fiber means it is one kind of a glass material. They are having a different classifications: core, cladding, and also a jacket. Core and cladding is made up of a glass material having a uniform refractive index, but having a certain difference values. So from the air medium, so we are going to send the propagation mechanisms through the optical fibers. So this is we are going to observe what angle of acceptance is here. Because so if the angle will be maintained properly, means it takes the refractions. The refracted light radiation will be at the interface of core and cladding grazes the surface or the scattering from the surfaces. It will be completely attenuations. But our intention is at the interface of core and cladding, the light should be takes the total internal reflections. Because of that reasons, we have to make it a total internal reflection in a acceptance angles. For that concept, here we are going to discuss acceptance angle through the Snell's law. So the incident and the refracted radiation propagate in the same plane, hence and applying the Snell's law usually from the air medium. You see, this is the air medium. In the air medium, if you apply the angle of acceptance, that is A, so light will be gets refracted. Now you see, in this angle, passing the refracted radiation takes the interface at the core and cladding. That is we call as critical angle. See, we call as theta naught. Then if you increase the angle of incidence, that is alpha. So the light will be also varies the critical angle. So it is more than the critical angle. So light will be takes the total internal reflection in these atoms. So after knowing, we are going to apply Snell's law to these equations. We are getting a using a figure, we are getting theta is equal to pi by 2, that is minus theta c, that is critical angle. On putting the value of theta from a whole equation in equation 1, we have get n1 sin alpha is equal to n1 sin of pi by 2 minus theta c. n1 sin alpha is equal to n1 cos theta c. So since we know sin alpha, sin eta 1 or n1 by n of cos theta c, we can rewrite this equation is cos theta c is equal to square root of 1 minus sin square theta c. So applying Snell's law at the core and cladding. This is for air and core. Next is applying for core and cladding. That is N1 and N2. So we can get it the equation number 5. So sin 90, we know the value. Then it becomes to N1 sin theta is equal to N2. So theta C is equal to N2 by N1. Substitute the above equation last previous, that is cos theta C is equal to square root of 1 minus N1 square minus N2 square whole square. Substitute the above equations in the 3. So then we are getting sin alpha is equal to N1 by N2, N square root of 1 minus N2 by N1 whole square. Sin alpha is equal to N1 square minus N2 by N. N means refractive index of the air medium. So after knowing this one here, for more specification we can use sin alpha is equal to square root of sin N1 square minus N2 square. So that is numerical aperture is equal to N1 square minus N2 square. So this is the angle of acceptance. This is the way here we are going to discuss the angle of acceptance in a numerical aperture or in a acceptance angles. So after knowing this concept, today we will discuss some multiple choice expressions. The expression for refractive index is given by, so N is equal to C by V. So velocity by N is equal to V by C by V. So next thing is numerical aperture is expressed as sin theta is equal to sin of theta A. So next is for a total internal reflection to occur, which condition must be satisfied? That is always N1 is greater than N2. N1 means refractiveness of a core. N2 means refractiveness of a cladding. So core refractiveness will be always more compared to the cladding refraction. Then only the light will be takes the total internal reflections in this order. So fourth one is find the refractive index of the medium having a velocity is 1.5. So here after doing the NA is equal to square root of mu1 square minus mu2 square concept, so we are getting the answer is 2. The refractance of the water will be, that is we know, D, that is 1.33. We discussed in previous class and also in a PFC. So it's about the acceptance angle of a numerical aperture concept or optical fiber concept. Thank you one and all. Thank you.